So a subway starts in Washington, D.C. and then accelerates. So, of course, I need some sort of origin, and then I'm going to start at the origin, and then I'm going to accelerate. Which means that what I have happening is that the dots are getting farther and farther apart. And ideally, each of the dots the spacing between the dots should get larger by the same increment each time, which I've pretty much done here. And so oftentimes people will draw a little arrow and the length of this arrow has some representation of the acceleration. And you'll notice that the gap between the dots grew by 1 square each time. Now, this is something that it doesn't have to be exact. This is a visual representation, and so we're not looking to have the exact mathematical representation, because if you'll see here that from the first dot to the last, that I certainly don't have 12 seconds, and there's nothing to suggest the 2 meters per second per second. So this is again just a visual representation. If we move to B, that this is vertical motion, which you can represent horizontally the way you see it here, just so it'll fit on the page. But later on you might decide that you'll draw it vertically just so it is more in keeping with what the representation actually looks like in the real world. And so what we have going on here is a pole vaulter just before touching the cushion has an initial speed, and then the pole vaulter comes to a stop. And so with these, you have to suggest what it is that's the initial condition. So the way I look at this is initially it is the instant that the pole vaulter comes in contact with the cushion, because if I go back in time, if they were falling, they would be speeding up, and what we're given here is a specific speed, so that must mean that was that instant right before they hit the cushion. You get to decide what direction is negative and what's positive, and so if I drew to the right as being positive, I would typically, because the way I think about this, if we're vertical, that up would be positive and the pole vaulter would be falling down. Now, there's nothing magical about that, but there you have it. So, what we have is a pole vaulter that has some position at the top of the cushion, and then over the course of time, and I'm just going to be kind of making this up, so that was 1, 2, 3, 4, 5, 6. We go down by 2. 1, 2, 3, 4. Now let's go back down 1, 5, and then 1, 2, 3. Perfect. And so the motion appears to be this way. Now, something that I forgot to put up here that is usually a good idea is that you draw an arrow with label A that indicates the direction of the acceleration. And you'll notice that the acceleration is the same direction in both of these, though the effect is different, because if the acceleration is in the same direction that you're moving, then you speed up, as is the case in question A, Whereas if the acceleration is in the opposite direction of the way you're moving, as in B, you slow down.